The core one function, like for me, the master OpenCV function is going to be MAT, and this stands for matrix. So for those that have taken a little bit of math, you're going to know that your matrix is going to really be an array of arrays, and when you declare it, it's going to be uppercase M AT. So this is the bread and butter. And when you want to store a video, it's going to be done in a matrix. When you want to take an image of something, it's going to be done in a matrix. And just a really great all-purpose container. There's some really great features with it and functionality to it. And we're going to go through some of them right now. So one of the things that took me a little bit of banging my head against the computer as far as how to access the matrix in different meaningful ways. So first and foremost, you're going to have different channels, right? So your average, just basic concepts of what makes up a video image, what makes up a video file. Well, you're going to have a 3-channel matrix, and you have a blue channel, a green channel, and a red channel. So all of the colors that your computer can see are going to be made up of some combination between 0 and 255 of B, G, and R. So this really, you'll have it's really a 3-channel matrix, and you might have MAT 0 is going to be equal to your blue matrix. Now, MAT 1 it's going to be equal to your green matrix, and it's blue, green, red is your red matrix. And now some of you that have taken art in elementary school might remember RGB, or like RGB I think is probably the more popular way to talk about red, green, and blue. But for OpenCV and most other applications, the red channel would be matrix 0 and the blue channel would be matrix 2. Now with OpenCV, they do BGR. So if you're wondering why your blue matrix isn't blue, it's because you're on the wrong matrix. So it is matrix 0 is your blue matrix. So now let's say that we have let's say that we want a matrix. You can initialize your matrix in a couple of different ways. So one of them is just this. If you just do MAT and say, some video, this will work just fine. You can plug in your webcam into that, and I'll show you how with a different function. But with this, it's going to be, it's kind of it's like a dynamic array where some video, maybe it's a 3-channel matrix, maybe it's a 1-channel matrix. MAT will kind of be an adaptable container that can take on any of these configurations. So later on, we're going to talk about switching color spaces, and that's one of the main things that you're going to want to do. And one of the core functions is to take a BGR video stream and convert it to a grayscale video stream. Well, aside from one being in full color and one being gray, the actual number of channels changes. So a BGR is a 3-channel matrix, and a gray is a 1-channel matrix. And you're able to make that conversion without having to change, with brute force, the number of channels on the matrix. So it's really a really good all-around container. Now, if you want to access each one of the matrix individually, and that's one of the things that you do when you start getting into light filtering, and some of the stuff I've worked on is illumination estimates for removing the ambient lighting from a scene, so you can start to get at the true color of things. And if you want to access each one of these matrices individually, you use this really well-named function called split. So what you have is, now with this would be how you declare your initial file, and you would put some video into here. Now, then you would have another one that's like MAT, we'll call it channels. and this would be a 3-channel matrix that we do statically define. So if you're going to split the matrices into its individual channels, you do need to hard code how many channels you're going to be splitting up. So you would then write split, and it's just your source. So it'll be some video, comma, the number of channels, and the destination. Just like that. So this will split, and you don't need to have the array classifier because it'll say how many channels it's splitting into. So now what you can do is access each one of these individually. So let's say you want to know what your average blue value is. Well, you can go through and with your mat, so now pardon me, it'll be channels 0, you'll be able to do plus equals. Actually, that would be pretty crummy code, but you could say, int blue val plus equals channel 0. So now what this will do, and this is one of the other nice things about the matrix class, is you can do item by item addition and operations without having to step through the full function. So the plus operator, the plus operator is overloaded, and this will actually sum all of the pixels inside of that blue matrix. And of course, you can do that for the red. You can do multiplication, you can do division, and each one of these functions, and depending on whether you want to do what types of division and addition you want to do, there's other added functions that you can call. But so if you want to, the point is that if you want to access individual channels from your 3-color matrix, that you need to split it up, and this is the function that you utilize. So next thing, so let's talk about, let me go to my topic sheet. All right, so the next thing that or one more thing that you can do with matrices, which is really nice, is access the rows or access the columns. So you can do something like mat.rows, and this takes a couple of different operators, and this is a very specialized function, but you can access all of the rows or all of the columns and perform the same task to all of them. So let's say you want to scale every column by a factor of 2, you can do that with this functionality. So now,
how would you cut like a piece out of the matrix?
Yeah, so you could do something like do a number of things. So one of the ways that I've done it is by using the at functionality. So you do something like, we'll go back to using one of these single channels. So we'll use channel 0. So you could say channel 0 dot at. Now you do need to put in what type of data that you're using, and the one that's just worked the best, and this is purely empirical. And also, I did not give my disclaimer. I'm certainly not an OpenCV expert. I've learned a couple of things just from practical usage, and there's a lot of great documentation online and a lot more material online. And this is, there might be quick, okay, awesome. And so this is the, just from purely in,
64 practice failed.
oh, not awesome. Okay, well, setup is complete, but yeah, and that's Visual Studio 2010, so we're fine. But so what I've seen work is you do uchar.
So what is uchar?
So it's an unsigned character, and it's pretty much the, now this gets deeper into the way that the matrix is actually built from like a
It's a class is structured, yeah.
Yeah.
But uchar isn't a CV type, it's just...
It's a primitive data type, and it's how the matrix is, yeah, it's how the matrix is built. So
you can say byte.
yeah, you can do byte, you can do int, you can do uint8, and it really depends. So it's a uchar if you do this declaration and initialization of matrix. But you can, if you know that you want a 32-bit floating point matrix, you can do something like M, and you can also declare and initialize the matrix to explicit values. You do have access to an explicit value constructor, so you can do something like 1600 by 1200, and now there are CV specific data types, and when you're constructing your matrix, you do need to use those, and it's stuff like all caps CV underscore 3C F32. And what this would be is a 3-channel matrix with a 32-bit floating point data type internally.
So it's like a three-dimensional matrix. So there's 1600 by 1200 by 3.
Yeah. So kind of a pictorial representation is, so like let's say that you have, this is kind of my favorite one, you have a tree, right? Like you have a picture of a tree. Well, what your computer is seeing is a number of different pixels. So each one of these pixels is actually 3 pixels. So now you have, and it would be blue, green, red, and you have the same tree, and each one of these is broken up accordingly, and same thing.
And that thing you just drew there is what the matrix is.
Up here. So yeah.
That whole thing.
Exactly. So this would be your standard matrix, your standard 3-channel matrix. And if this is, if the tree has green leaves, you'll have some blue value to be like, let's say 50. Your green value will be super high, and you might even have some red in it. And so this would be the blue value, the green value, and the red value at pixel. In this case, it would be like pixel 4, 3. One of the other things of note is when you access the pixels on a pixel by pixel basis, the order is it's rows, columns. So it's Y, X is how it's accessed. So I think everybody here's, or at least for me personally, I'm trained to look at X then Y. But if you say you want to access this specific pixel, you do Y then X.
Was it remember that how you iterate through matrices by row then column?
I'm not sure that there is a normal style to iterate. Like there's the ways that I've normally done it. It by no means is that the standard, but you could do either or. Like you could, row column.
Restart.
Okay.